Well, good evening, ladies and gentlemen. I am reviewing a problem that I told you I would review on the study guide for Unit 7. The question that was on study guide was number 3 on the study guide. When I look back at it, it was a little more complicated, and definitely there was no way to do it quickly. So I've decided that what I'm going to do is I'm going to replace that question on the test with one that is easier to solve and doesn't involve all the extra steps that one involved. So this is the example problem that you're going to have like on the test tomorrow. So we're going to start with 3x to the third minus x to the second minus 6x plus 4. Now remember, because this is a 4-term polynomial, we're going to use factoring by grouping to factor it, and then once we factor it, we're going to solve for x for all of our resulting binomials. All right, so we look at the first two terms and the second two terms as a pair. Let's take care of the first pair. All right, if you look at 3 and the invisible 1's in front of x squared, there's no greatest common factor other than 1, so we can't make it smaller. Remember, the purpose of a greatest common factor is to make the binomial smaller or the term smaller. If it doesn't change and become a smaller number, we can't use it. All right, so now let's move on to our variables. Okay, we have x to the third and x to the second. So remember what I told you in class. It's easier to come down an exponent than it is to go up an exponent. So we always pick the lowest exponent. So in this case, it's going to be x to the second. So we're going to have x to the second, and then we're going to start factoring. All right, so the 3 is going to stay because we didn't have a number we were going to reduce it by or divide it by. However, when I have x to the third, we're going to divide it by x to the second. So remember in class, I would always use the analogy of if we got 3 x's, I take away 2, how many x's do I have left? In this case, we're just going to have 1x, okay? Then we move on to our x squared. Well, if I have 2 x's to begin with, and I need to take away 2 from them, I'm not going to have any left. So we're just going to have a negative 1 as our final answer because that was what was in front of our x squared, all right? Then we move on to our other two terms, negative 6x and positive 2. Because this is a negative 6, we want to pull that negative out because, remember, we want it to look like what's in the first set parentheses. And if you notice, the first term here is a positive 3, not a negative 3. All right? So let's look at 6 and 2. The greatest common factor between 6 and 2 is 2. But remember, I told you it had to be a negative, so we're going to put a negative 2 here. All right? Then we're going to start parentheses. Now, negative 6 divided by negative 2 is positive 3. We didn't have an x, so we couldn't take away any x's, so we're going to just rewrite our x. And then we're going to say positive 2 divided by negative 2 is negative 1, okay? So now we have the same thing in both parentheses, here and here. So we're going to rewrite that as our first binomial, 3x minus 1. And then we're going to take the other two terms that were outside of them and create a binomial. In this case, we have x to the second minus 2. All right? So now we have two binomials, and to solve them or find our x-intercepts, we're going to set both of them equal to 0. So the first one we're going to do is 3x minus 1 equals 0, and the other one we're going to have is x squared minus 2 equals 0. All right, so let's go ahead. All right, so let's start with the left one. All right, first thing I want to do to isolate x is to add 1 to both sides and wind up with 3x equals 1. All right, then the last thing I want to do, because I want to isolate x or get it by itself, what I want to do is I want to divide, because that's the inverse operation of 3 times x, and divide both sides by 3. What happens is those cancel out because 3 divided by 3 is 1, and we're going to be just left with x on the left and positive 1/3 on the right. Leave it as a fraction. All the answers on the test on this particular problem will be fractions, and you'll see the other type of answer we'll have here. All right, the next one we have is x squared minus 2. All right, here we're going to add 2 to both sides. All right, and we're going to wind up with x squared equals 2. And remember, to get rid of our square, we have to do the inverse, which is to find the square root of both sides. Now, 2 is not a perfect square, so we're going to wind up leaving it inside the radical because there's also not a perfect square factor other than 1, which, again, remember, it's not going to make it smaller. So we're going to say plus or minus the square root of 2. All right? So for this problem, our zeros x-intercepts are 1/3, comma, positive square root of 2 and negative square root of 2. And that will be our answer. So on the test, you will have something very similar to this. Now, you may have one that has an I in the answer, and right before the test tomorrow, I'll work out one like that so that you see both types. So please review this one because, again, it's going to randomly generate. So some of you, depending on what form you have, may have the one with an I in it. Some of you may have the one without an I. All right. Well, thank you for your attention, and good luck on the test. Remember, study your study guide. And remember, this will be the question that asks you to find all zeros will look very similar to this and the one I'm going to do as an example before we do the test. Thanks, and I will talk to you in the next one, and I'll see you tomorrow. Bye.